Hey Red Devil Chemist, how you doing? It's Coach Scott with another episode of Let's Work Through Some Problems. So again, we're working on worksheet 4S tonight, and let's work on problem 16, which was a problem for a lot of you guys, right? So this is a combustion analysis problem with some other little side fun things thrown in. So we'll do the best we can to get this where everybody understands it. So let's see to read a problem. The combustion of a 4-gram sample of a compound that contains only C, H, N, and Br yields 3.826 grams of carbon dioxide and 2.087 grams of water. So from that information we can get the number of moles of carbon and we can get the number of moles of water, right? We'll work through that. Another sample, again, let's separate these, right? Because right now I can only get carbon and hydrogen. I can only get the number of moles of carbon and hydrogen. By doing that, I can get the percent of the compound by mass of carbon and hydrogen, right? I don't have nitrogen and don't have bromine yet. There's not enough information. But let's read on. Another sample of the compound, totally separate event, with a mass of 3.111 grams. The total is found to contain, by some method of analysis, 1.803 grams of bromine. So, and what's the empirical formula of the compound? So I've got two steps here, and if I get the percentage of bromine, which I can now, that means I've got bromine, I can calculate carbon, I can calculate hydrogen, the number of moles, which means I can get the percentage, right? And so if I can get the percentage of bromine, I've got 3 out of 4%. Now I can get the percentage of nitrogen. So let's figure it out. All right, so I've got carbon, I've got hydrogen, I've got nitrogen, and I have bromine. All right. So let's go ahead and get our table together because we're going to have to get the percentages of all of these. So let's go carbon, hydrogen, nitrogen, and bromine. So I've got an empirical formula problem. All right. I've got a combustion analysis problem. So let's go ahead first, because it's going to be pretty easy. Let's get the percentage of bromine. So I've got to look at this second sample, 3.11 grams. This is the total. Contains 1.803 grams of bromine. All right, so if I got 1.803 grams of bromine and 3.11 grams of sample, that's going to give me a percent of bromine. All right, 1.803 divided by 3.111 grams. All right, times 100. That's going to give me 57.96 percent, 0.96% of bromine. So I can even write that over here, 57.96, and we'll assume it's out of 100. So now let's do some combustion analysis. All right, so I'll use red. All right, so it tells me that I have 3.826 grams of carbon dioxide, 0.826 grams of CO2. So I know something. For every mole of carbon dioxide, there is 1 mole of carbon, right? So I've got a mass of carbon dioxide. So now I can get the number of moles of carbon dioxide, all right? Okay, and then from that I can reason out and get the number of moles of carbon. So, all right, carbon dioxide, I've got to get the formula mass of that. So that's 1 carbon, 12.011, plus oxygen, 2 times 16, 32. That's going to give me 44.011 grams of CO2. All right, CO2, CO2. That's going to give me moles of CO2. Okay, so that's 3.826 divided by 44.011. That's going to give me 0.0869 moles of CO2. Let's leave that alone for right now. Now we know from combustion analysis, that if I have H2O, right, it gave me my mass of H2O is 2.087 grams of water. All right, and I can calculate the number of moles of water. All right, the number of moles of water. All right, is 1.0079, the mass of hydrogen, times 2 plus 16. That's going to give me 18.015. Okay, and if I divide that, or 2.087, by the atomic mass or molar mass of water, that's going to give me 2.087 divided by 18.015. That's going to give me a atomic mass, or excuse me, a formula mass of the water in the sample of 0.1158 moles. I said formula mass. I didn't mean to say that. All right, of water. So let's reason this out. For every 1 mole of water, there are 2 moles of hydrogen. So now there's 2 moles of water. If I multiply that by 2, that's going to give me the number of moles of hydrogen that came from that compound. Because we know that this compound, burned in oxygen, will give us CO2 and water and other stuff, right? But now we can figure out the number of moles of hydrogen that this combustion provided. So if I do that, that's going to give me 0.2317 moles of hydrogen. All right, so I got the number of moles of carbon. 0.0869 moles. I got the number of moles provided by the sample of hydrogen, 0.2319 moles. Now, if I can get the mass, which we can do, of the carbon and the mass of the hydrogen provided by the sample, then I can get the percentage, because I know the total of the sample, which was 4 grams. And if I have the percentage of that and the percentage of that, then I can get percentage of that, because I've got that. Okay, so carbon, I've got that many moles. Okay, and if I multiply it by the atomic mass of carbon, 12.011, that's going to give me 0.869 times 12.0111. That's going to give me 1.0437 grams of carbon provided by the sample. Okay, and then if I multiply that by the atomic mass of hydrogen, all right, cancel out the moles, it's going to do that one too, 0.2319 divided by, or excuse me, multiplied times 1.0079, That's going to give me the number of grams of hydrogen provided by the sample. 0.2337 grams of hydrogen. So now if I take that number, take it down here, 1.0437 grams, and if I divide it by the total 4 grams of sample, okay, 1.0437 divided by 4 grams of sample, that's going to give me the percentage It's going to give me the percentage of carbon, which is, where y'all can see, 26.09%. So now I can write this up here in my box, 26.09%. So now I can get the hydrogen. Let's move this down a little bit. So the hydrogen, okay, is 0. Let's take this over here. 0.2337 grams. All right, if I multiply that by the relative atomic mass, okay, or divide it by that, okay, or excuse me, if I divide that now by the total sample, almost messed up, 4 grams, that's going to give me the percentage of hydrogen, 0.2337 divided by 4 times 100, and that gives me 5.84% hydrogen. Problem's almost done now. We've already done the hard part. So we'll write that here. 5.84%. All I'm needing is nitrogen. But if I take 26.09% plus 5.84% plus 57.96%, it will give me the percent of nitrogen. So let's do that. 5.84 plus 26.09 plus 57.96 minus 100. That's going to give me 10.11%. 10.11% nitrogen. So now I've got the percentage of all the elements in that compound. And so now, got to use that molar mass thing again, right? So the atomic mass of carbon is 12.011. The atomic mass of hydrogen is 1.0079. Nitrogen, 14.007. 14.007. Bromine, we don't use that much, so I don't have that one memorized. Bromine is 79.90, okay, grams per mole. So this is going to give me the number of moles. We've got a simple empirical formula problem now. So 26.09 divided by 12.011 is going to give me the number of moles of 2.17 moles. 5.84 by 1.0079 is going to give me 5.8 moles. 8 moles. And we'll say 79 moles. All right, and then 10.11% divided by 14.007 is going to give me 0.722 moles. Then 57.96 divided by 79.9 is going to give me 0.722 725. So now, what do we have to do? We have to find the smallest number of moles, which is going to be the 0.722, and divide everything by the smallest amount of moles to get a whole number. 722, that's going to give us a 1. And then 725 divided by 0.0722, 722. It's going to give us a 1. If we divide everything by 722, see what whole numbers we're going to get. That's going to give us a 1, 1, and then 5.79 divided by 722. That's going to give us an 8. All right, then carbon. All right, so 2.17 divided by 0.722. That's going to give us a 3. So everything is a whole number. So that's going to give us, we're just going to transfer these over here now. So that means I have 3 carbons. I have 8 hydrogens. I have 1 nitrogen, 1 bromine. That's it. That's the empirical formula. That's the whole problem. So I think you guys have this. So I circle that right there. So there is problem 16. I know that was giving a lot of people problem, and it's really because trying to think about how you're going to get the percentages of all those elements. And if you think real hard, you can, because if I have 3 out of 4, I can get the rest. So